Hello and welcome. Today I will be talking to you about the impact of poultry house pollution on our local watersheds and why we should be concerned about it. I am your host for tonight, Victoria Prater-Rochier, and I could not have done this presentation of my research without the help of Dr. Alan Dodd and Dr. Paul Beebe. So without further ado, let's talk about chicken poop soup. Before we get started, I wanted to break down some terms that I will be using throughout our time together. Eutrophication is a fancy word for out-of-control algal growth in water. This can be detrimental to water life, as we will see in a minute. Interflow is the term ecologists use to describe the movement of water underground and laterally. Think back to grade school science. You know water is recycled through a process of evaporation, condensation, and precipitation. Of course, it's a little more complex than that, but we'll skip the nitty-gritty and focus on one detail, interflow. As rain soaks into the ground, it grabs nutrients along the way and joins the interflow system. This interflow system can have a great impact on nutrient distribution in larger water systems. Water systems like streams have a wide variety of organisms, things like bacteria, bugs, fish, and plants. A healthy stream system has a good balance of these organisms, aka stream equilibrium. An unhealthy stream system has an imbalance where one organism has dominated the stream's resources. This is an example of a healthy stream. So how do we get an unhealthy stream? One way to cultivate an unhealthy stream is to expose it to nutrient-rich substances like chicken poop. Chicken poop is high in nitrogen and phosphorus, and when it is introduced into a stream, the stream sees a boom in plant life. Nutrients is necessary for proper stream health, but remember, equilibrium equals a healthy stream. When excess nutrients is introduced into a stream, algae proliferate and grow. Their expedited growth rate can be disastrous for a healthy stream, however. Algae suck the oxygen out of the water, and more algae means less oxygen for other organisms. The other organisms will die off, and the stream will be deemed unhealthy. So why do we care about chicken houses that provide us with delicious fried chicken? Well, it's not the fried chicken that's concerning, it's the other products of chicken rearing that we should be concerned about. Chickens poop between 11 to 15 times a day, and it's high in nutrients. Improper storage of chicken poop can lead to nutrients seeping into the interflow system and collecting in larger bodies of water. Okay, so that was a lot of information that I just threw at you. So here is a mandatory brain break. Did you know that chicken poop can be made into a moisturizing lip balm? I mean, at least there's one use for that nutrient-dense litter. I'll let you decide whether that is a good investment or not, but your brain breaks over now. Poultry houses are popping up all over the country to meet our ever-growing population's food demands. These aren't your cute little hutches that you built with grandma and grandpa. No, these are industrial-sized warehouses that hold up to 20,000 chickens each. One warehouse produces 2.5 million pounds of chicken poop a year. That's a lot of waste for one warehouse, and usually houses are clustered on a farm. To see how this clustering of poultry houses impacted water quality, Dr. Dodd and our research team set out to find answers. On this map, the red dots represent poultry house locations, and the green triangles are streams we sampled from. As you move south, you see an increase in poultry house clustering, so this was the perfect way to see how poultry houses impacted local stream systems. Looking at the phosphorus levels in streams we tested, there was a correlation between phosphorus and poultry house density. As poultry house density increased, phosphorus levels within the streams increased. Our two outliers, Tennessee and Hubble, had extremely high phosphorus levels in a low density location. These two had houses directly upstream from our sites, leading us to believe that proximity may also play a role in stream health. As water quality declines and algae take over with excess phosphorus from chicken poop, the food web is impacted. Stream bugs and fish die, their deaths mean less food for larger predators, so they die, and the chain continues up the web until the whole thing either collapses or the animals adapt. But this could potentially disrupt other food webs. Streams are part of a larger system, and they feed into rivers leading to the Gulf. By feeding into other systems, the unhealthy streams carry their phosphorus-rich poop water into previously healthy streams and infect them. We can actually see this collecting nutrients in the Gulf of Mexico's dead zone. Here, eutrophication is rampant and organisms cannot survive within it. Eutrophication also impacts our drinking water. Excess algae is troublesome for water treatment. It clogs up the machines, increases disinfectant demand, makes the water taste and smell funny, and much more. The chances of pathogenic exposure increase with high levels of algae. The toxins produced by eutrophication and using excess disinfectants increases the risks of cancer. I know all of that was scary to learn and think about, but it is important to acknowledge that our food needs are negatively impacting our overall health indirectly. By increasing poultry houses, we effectively increase food production, increase phosphorus in groundwater, increase eutrophication, and increase negative impacts on food webs and essentially our health overall. But food is necessary for survival. So, what is the solution here? And is there even a viable one? What can we do so that we can keep food production up while minimizing the effects of poop produced by soon to be chicken tendies? Honestly, there is no easy solution to our question here today. Currently, there are a few federal and state regulations that chicken farmers must abide by. They must adhere to the protective rates of chicken poop fertilizer application and conduct soil tests. If an area has been deemed at risk for overnutrification, farmers are required to adopt and abide by a nutrient management plan. Poultry houses have to have approved poop storage facilities and proper irrigation as well. These rules and regulations aren't enough, however. We need to focus on clustered poultry houses because our data shows that house density can impact phosphorus levels within a stream. We should also look closer at limiting poultry house proximity to streams as we suspect that a vegetative buffer benefits stream health. We also need to hold chicken farmers more accountable when they fail to meet federal and state regulations. In the end, we know that poultry houses are impacting water quality in our own backyard. When stream health declines because chicken poop seeped into it and caused an algal bloom, the impacts are greater than some fish dying off. We risk disrupting complex food webs and our own health. So the moral of the story? Don't let the chicken cross the stream. Thank you for listening to my Pecha Kucha on the impacts of chicken poop and water quality. Of course, none of this would have been possible without Dr. Dodd, Dr. Beauty, and all of these wonderful resources. If you have any questions, please feel free to email me at victoria.praterrochier@lyon.edu. Thank you.